Welcome, ladies and gentlemen, to a new episode about Alusus programming language. In this video, I'm going to talk about database migrations. In a previous video, which you can find on this channel, we've talked about the Rows ORM for Alusus language. So you can refer to that video for more details about the ORM itself and how to build your models and use them. In this episode, I'm going to talk specifically about doing database migrations. In the Rows library, which you can find on GitHub, and I'll leave the link to that video in the description of this video. I'll leave the link to that GitHub repo in the description of this video. But anyway, in that repo, you can find a few examples under the examples folder. One of them is migrations. And this example just shows how to do migrations. Before I talk about how migrations are done in the Rows library, it's important to note or to remind people how migrations are done in other libraries like SQLize or Active Records or many others. The migrations in those libraries are done linearly. So you basically, when you start a new project, and start adding models, you define migrations that are run sequentially. So you have a separate folder for migrations, and then each time you want to make any change to the database, you add a new migration file. And these migration files are numbered so that they can be sorted sequentially and then executed sequentially. And that's important. They need to be run in the right order because some migrations might depend on others. So there are a few problems with that approach, and one of them is that over time these migrations will accumulate, and then you'll have a long list of migrations in your project, which you can squash into a single migration over time, but that's a lengthy process. It's not very straightforward. Most people don't do it, and so most projects you look into, you'll just find a long list of migrations. The other problem is that if you want to know the current shape of any table, you have to go look through these migrations because that's basically your source of truth of how the database look like. In some libraries, I know like Active Records always generate a single file that has the current shape of the database, of the schema, basically just to overcome this problem of having to know what the current shape look like. Other people just have to log into the database and look directly at tables and see how they are. So these problems, there's also the problem of conflicts. So if you have multiple people working on different features, or maybe the same person working on multiple features in different branches in the source control, and then needing to merge those, if each of these creates its own migration, when you merge them, you have to make sure the numbers don't conflict. So these are few problems that people face with the linear style of doing database migrations, which is and this is something that the Rows ORM library for Alusus language solves by doing following a different approach that's kind of unique. I haven't seen it anywhere else, and this is what we're going to look at here in this video and in this example. So let's take a look at this simple example. We have a vehicle model. It has this model tag. It tells it to create a table with the name vehicles, and it has ID, name, price. As you already know, when you run the database, you can tell it, you can like db is the actual database object, and then you can do dot schema builder, give it the schema, and then call migrate, and this will bring your database to up to date, basically to the current shape of the models. And here schema is basically defined as we have a single table, which is vehicle. So what this does is that it basically creates a table for you. You don't have to create any migration yourself. the database engine will create that for you. Now, if you're working on a new project, this is fine. You need a new database anyway, so the engine is creating it for you, and it's creating it to follow this exact pattern or schema as it is in the source code. Now, once you run this in production, you'll have data in that table, and at that point, if you want to make changes, you can't just recreate the tables because obviously there are data that you don't want to lose. And this is where migrations come in play. So you can notice here that we have this number that follows after the table name, and this number is the version number. So in the rows library, every model has a version. So unlike things like SQLize or Active Records, where the whole database has a version number, in Alusus every table has a version number. And so when you migrate, you basically just worry about that single table, and this saves you from being in conflict with other migrations. So let's look at the second part of this example, where it's actually migrating this vehicle model. So it's the same model, it just added a new field to it, which is called year. We updated the version to version 2, and now we need to tell the engine how to migrate from version 1 to version 2. And this is done by simply creating a function and giving it the migration modifier, and giving it two parameters. First is the current version, and the second is the new version. So this basically tells the engine that this function is to migrate this specific model from version 1 to version 2. And then inside this function, you can execute whatever you want. You can execute a raw SQL query. You can execute queries using the ORM itself, whatever. It doesn't care how you execute. It doesn't care what you do here. It just runs this function, and then it returns an error if things fail or not. So that's the basics of this. And then if you are going to make another version, or sorry, like in the future, you want to make another update. Let's say you have another version, so you can just run a new one or create a new function, give it from version 2 to version 3. You can give the function whatever name you want, and then here you can do whatever work you want. So and so basically, whenever you need to change from one version to another, you add a new function, you give it the from and to versions, and then it will run it for you. And it will automatically find all the needed functions, and it will run them in the right order. So in this case, sorry, we need to update this to version 3. So in this case, when you run this on an existing database, it will check the current version of that table in the database. If it's on version 1, it will run this function, then will run this. If it's already on version 2, it will skip this and will run only this. So so you just basically add the functions that does the migrations, the partial migrations, and then it'll running them in the right order is the responsibility of the engine. You can also do, like, you can skip these, and I can't really think of a reason why you might want to do that, but if you do like another function that migrates from 1 to 3 directly, and then remove this, then yeah, you can do that as well. But obviously, if something is on version 2, then it won't find a migration function, and it will fail. The other thing, let's undo this. The other part of this example shows how to migrate when there are multiple tables involved. So in this case, what we want to do is we want to extract the price out of this. If you look at this table, we have this price field, and in this new migration, we want to extract that price field into a separate table. And this is done simply. We just create a new class, a new model called price, give it the columns. This is a new model, so we give it a version 1. Since it's a new model, it doesn't exist in the database, we know we don't have any data to worry about, so we don't really need to create a migration. We can just let the engine create the table for us. So we don't create a migration here. We let the engine takes care of this. Now the other part is taking the current data from the current table into this new table and then removing the price. And this needs to be done in 2 steps. In first step, we need to copy the data, and then second step, we need to drop. And that's why you can see here, we bumped this to version 4, and then we added 2 migrations, one to migrate from version 2 to version 3, and then the second one to migrate from version 3 to version 4. The 2 to 3 migration simply does the insert into the new table by copying it from the current table, and then the second migration simply drops the new table. So it's very straightforward. But the thing to keep in mind here is that we cannot run this until the price table is created. So we do this by telling the engine that this migration depends on having table price existing at version 1. So, and the engine will take care of that. Now, let's say you have, let's say there's another table also required. For example, price or currency, for example, whatever. So if you have multiple tables that all must exist, you can just list all your dependencies. You can have this on version 2 or whatever, and the engine will take care of finding all the needed tables, create them if they're not existing, migrate them if necessary, and then running things in order. So let's say you want this on version 2, and then you have theoretically speaking, or hypothetically speaking, let's say you already have a price table, but you want to migrate it to version 2, and you have this migration function, and you want to make sure that this migration in the vehicles table doesn't run until price is on version 2, then you just need to tell it, I want this to be version 2. Then the engine will know automatically that to run this migration first before running these 2. You can also do things like make a change in one table, then run the migration in another table, and then do another change, a follow-up change in the same old table. So whatever order you want, you can just control that through the dependencies. So let's say if you do this, or let's say if you do this, for example, and then you do this, for example. So in this case, I mean, let's assume we already have the table, or let's assume this is version 3 and this is version 2, this is version 3. So this will guarantee that it will run this migration first, then we'll run this, and then we'll run, if we have another migration that migrates from 2 to 3, it will run that, and then price will be on version 3, and then it will run this. So it takes care of everything for you. You just specify dependencies, make sure they're in the right numbers, and the engine will take care of everything. So let's undo all these changes and look at another case. So let's assume you need to make changes that are not specifically tied to a table. As for example, you want to make some data transformation that involves multiple tables, or you want to make changes in multiple tables and want to run them in a transaction for whatever reason, things like that need to have a migration that are not tied to a specific table. You can still do that by using a virtual a virtual table, which is you define a class, you define it as a model, you give it a name for a table, but you don't actually create the table, and you don't let the engine automatically create the table for you. And this is done by creating a migration yourself and giving it the source version number to be 0. So this tells the engine, if you were migrating from version 0 to version 1, version 0 meaning the table does not even exist, then run this instead of creating your own migration. So if you don't specify, if you create a table and you don't specify a migration and you give it a version, so its current version is 0, the engine automatically creates a migration from version 0 to the current version. That is done automatically by the engine. But if you create your own migration from version 0, then the engine will assume that you want to take care of creating that table yourself, and it will not do the automatic table creation for you. So in this case, if you create a model, give it whatever name, and you specify the migration from 0 to 1, and then your migration doesn't actually create a table, but actually does something else, like updating the data of another table, the engine doesn't care. So it will just assume it has a table with this name, assume it's gonna be on version 1 after you run this, and that's it. So in the table where the version numbers are stored, this will be there as a virtual table at this version, but the engine doesn't care that the actual table is actually a table in the database itself. So yeah, that's basically it. So you have full control. You get basically you get all the benefits. You don't have any conflicts when you work on when multiple people are working on multiple models at the same time. You don't have accumulation of of migrations. Once this is run in production, and you know that this table, there's no longer a version 2 of this table anywhere, they can just go and delete that. You don't have to worry about squashing migrations or doing whatever. Anything that's already gone and not needed, you just delete it from the source code. So there's no issue of piling migrations. You also have every table has its own migrations built into it, so it's easy to find all the migrations specific to a table. It's easy to know the current shape of a table by simply looking at the class, and yeah, so it's basically just much cleaner compared to a linear migration system like the one that's in SQLize or Active Records. And that's yeah, that's pretty much it. With this, I'll end this video. I'll leave links to this repo and to an article that explains whatever we just talked about, explained in text for those who want to read or refer to in the future. I'll leave the links for those in the description of this video. Thanks again for watching, and see you in the next video.